Hello everyone, welcome to my YouTube channel. Myself Antil and I am going to start your first chapter of class 12th of your physics section. This is electrostatics. This is your first lecture. Let's start. What does electrostatic stands for? In the word electrostatics, the word electro means charge and static stands for rest. So the branch of physics in which we deals with the study of charges at rest and their characteristics, whatever they possess, like they can apply force, they can produce electric field around them, they can produce electric potential around them, whatever the property a charge can have which is at rest, we are going to study in electrostatics. So the branch of physics in which we deals with the study of charges at rest and its effects like electric force, electric field, electric potential, etc. is known as electrostatics. So in this unit we are going to study the charges at rest. Now I am going to remind you about charges which you have already studied in your previous classes, like in 10th class. You are studying it, although from your 7th, 8th, 9th, 10, in every class you have studied about charges. So I am not going to repeat them, I am just going to remind them to you. So first question is, what is electric charge? What is electric charge? So I think that most of you can answer that. Electric charge, it is the intrinsic, you can say internal, this is God made, not man made thing. It is the property of any matter. It is the intrinsic property of any matter, due to which this matter can apply or experience electric force. So we have studied four fundamental forces in nature in your 11th class. The one was gravitational force, the other one was electromagnetic force, other one was weak nuclear force and strong nuclear force. So the electromagnetic force, the reason the electromagnetic force was come into existence, the reason is electric charges. Electric charge is the property of a matter due to which this matter can apply or experience electric force from another charge. Alright, that was electric charge for us. What is unit of electric charge? So we have SI unit of electric charge, that is Coulomb. It is the name of scientist, so its symbol is capital C. The CGS unit of electric charge is either you can say electrostatic unit of charge. It is also known as ESU. It is also called as stat coulomb, or it is also known as Franklin. Alright, so what is the relation between this SI system and CGS system? So we have 1 coulomb equal to 3 into 10 to the power 9 ESU. You will remember that. Alright, okay. Now you also know that there are two type of charges. There are two type of charges. Whatever are they are, one of them is positive charge and another one is negative charge. You also know that like charges means the charges of the same nature repel each other. Like charges repel each other and unlike charges attract each other. Alright. So what is the smallest charge possible? So we have quarks which have charge equal to 1 by 3 times of charge of electron. Electrons charge 1 by third charge, 1 by third of charge of electron, but quarks cannot remain independent. Quarks are the particle which made proton and which made neutron. 3 quarks combine to form protons and 3 quarks combines to form neutron, but they cannot remain independent. They always comes into pair, whether the pair of 3 quarks or whether the pair of 5 quarks, but they cannot stay independent. So the smallest charge which can stay independent, which can transfer independently, that is the charge of electron. So the smallest charge, the smallest charge which can which can stay independent, is the charge of electron, So how much charge does electron have? We all know that from your class 10th, the charge of electron is minus 1.6 into 10 to the power minus 19 coulomb. What is the charge on proton? Proton have the charge of the same magnitude as that of electron, but it is of positive nature. So proton have plus 1.6 into 10 to the power minus 19 coulomb of charge. How much charge does neutron have? So neutron is a neutral particle, so it has 0 coulomb of charge. Alright, this is what we know till now. Now the question is how the charge comes on a matter. We all know that in a natural form all the matters are in neutral form. Then how come the charge comes into existence? What is the origin of charge? This is our question, and we are going to answer that. What is the origin of charge? What is the origin of charge? Origin of charge. I am going to take a very short example of the formation of common salt, that is NaCl, sodium chloride. In NaCl we have an atom of sodium which have atomic number 11. If I complete its cell, the first cell contains 2 electrons, the second one 8 and the third one is 1. And the chlorine have 17 atomic number, and if I fill its cells, then it will have 2, 8 and 7 configuration. Now we all know that octet rule, from octet rule, that atom is most stable in the last cell whose there are 8 electrons are filled. So sodium have a tendency to lose 1 electron and chlorine has a tendency to gain 1 electron to complete its octet. We all know that from your 9th class. So sodium have a tendency to lose 1 electron and chlorine have tendency to gain that electron. Now from the start, if I will see the sodium atom in the free state, in the natural form, it is neutral. That means it have 11 protons and 11 electrons. As 11 protons have positive charge and electrons have negative charge, so it has equal positive and equal negative charge, which combines to form 0 charge initially. Now I will see about chlorine. It is also in natural form is neutral, so it have 17 proton and 17 electrons, so equally positive charge and negative charge are equal, so the net charge is 0 here. Alright, so when sodium try to gain stability, and in order to gain stability it loses an electron. Every atom, everything in this universe wants to gain stability. They do whatever they can do to gain the stability. For example, you are studying just to gain stability in your life. You want money, you want home, you want dresses, you want to complete your dreams just to gain the stability. So you are going to educate yourself so as you can become successful in your life. So everyone have a motive, and indirectly everyone wants to gain stability. So as atoms want to gain stability, and for that there is a rule, octet rule. If atoms have 8 electrons in their last cell, they are being more stable, like the noble gas configuration they will attain, so they will become stable. So in order to gain stability, sodium wants to lose 1 electron. Alright, when the sodium lose 1 electron, it gets let's see the scenario again. It have initially 11 protons, it does not lose any proton now, so it has 11 proton before and 11 proton now. Now it loses 1 electron, initially it has 11 electrons. Now as it loses 1 electron, so it must have 10 electrons now. So the charge is in balance, the positive and negative charge in balance, so it have plus 1 coulomb of charge, or you can say that plus 1 unit of charge, not coulomb. Coulomb is a bigger unit. When one electron, when an atom loses 1 electron, it does not mean that it gets a charge of 1 coulomb. We will come to that later. Now in order to gain stability or complete its octet, chlorine gains 1 electron. So let's see the scenario here. It does not loses any proton or does not gain any proton, so it has still plus 17 number of protons, but it gains 1 electron. Initially it have 17 electrons, now it gains 1 electron, so it have 18 electrons now. So there is imbalances of positive and negative, so we know that clearly it has negative is more, so 1 unit of charge of negative comes into of chlorine. So chlorine become negative ion and sodium becomes positive ion. There is electrostatic attraction between positive and negative charges, like we know that unlike charges attract each other. So there is an ionic bond between them. I am not going on that, but see how chlorine and sodium get its charge. They get its charge when the electron is transferred from sodium to chlorine. So a body gets charge when electrons are transferred from them. What is the origin of charge? I have given you the answer of that. What is the origin of charge? The origin of charge is, in order to gain stability, when atom either lose or gain the electrons, this is the reason, this is the origin of the charge. In order to gain stability, atoms oftenly lose electron or gain electron. So transfer of electron is the reason of gaining the electric charge on any body. So origin of charge is due to the transfer of electron, due to the transfer of electron. The origin of charge is due to transfer of electron. The body which loses the electron gets positive charge. We will write further, the body which loses electrons gets positive charge, and the body which gains the electron gets negative charge, and the body which gains electrons gets negative charge. So how a body gets charge? By losing or gaining the electrons. Alright, this is how come the electrons transfer is the reason for a body being charged. Alright, now the question is, we are going to study electrostatics, in which I have already told you that in electrostatics we are going to study the charges at rest. The question is whether the charges actually stays at rest. We have studied Rutherford model in class 9 or Bohr's model in class 9, which says the atom have nucleus in its center and electrons are revolving around it. Alright, electrons are revolving around it, not at rest. Electrons are revolving. In fact, the nucleus is also revolving. If we study in deeper, you will go to the nuclear physics in the in your graduation or post graduation, you will see that nucleus is also moving. Nobody is at absolute rest in this universe. So this charge is also moving, this charge is also moving. Then how come you find the charge at rest? Charges are moving. So only at 0 Kelvin, that is called absolute temperature, we consider that electrons are at rest, but 0 Kelvin is the temperature approximately minus 273.15 Kelvin, minus 273. That is very less temperature, and normally we don't have that less temperature on earth. So this is practically not possible to do so. So how we are going to study this whole unit where charges are at rest, and in practical scenario we see that charges does not stay at rest. So as the charges does not stay at rest, but we can make the charges to stay at rest, so I am going to show you that how comes the charges stay at rest in this unit. Alright, so question is how the charges stays at rest. How the charges stays at rest. Alright, question is how the charges stays at rest. So in this unit we are going to see the method how we are going to make the charges at rest. Then the one method is we will use insulators. You also know insulators by the name non-conducting materials. as the non-conducting materials, you all know that those materials which does not allow the flow of charges from them are known as insulator or non-conducting materials, and conductors are those materials which allow the flow of charges from them. For example, wood, plastic, etc. are non-conducting materials, and iron, copper, aluminum, silver or are conducting materials. All right. So for making the charges at rest, either we will use insulators. What is the property of insulator? Once you have given some charge to an insulator, it will stay where it is created. Right. I will not use the word created, as charge is conserved, so it cannot be created nor be destroyed. So I will say whatever charge is put on an insulator, it will stay there, as it cannot move on an insulator at its property. Charges cannot flow on an insulator. All right. So for example, I will give you some example of this. You have also learned in your previous classes, when one rub a glass rod with silk cloth, glass rod rubbed with silk cloth, it gets charged. Right, it can attract the other pieces, yeah, or it can attract or repel the other glass slab which is also rubbed with the silk cloth. If we put two glass rod which is rubbed with the silk cloth, they will repel each other. It means they get some charge. All right. So by rubbing the glass rod, we get some charge on the glass rod. Why? As the glass rod is insulator, and when we rub it, we apply some energy in rubbing against the friction, and that energy converts in the form of heat, and electron absorb that heat, and after absorbing that heat, electrons get free. So when the electron gets removed, the glass rod gets positive charge and silk cloth gets negative charge. That is not a matter of concern which one get positive charge and which one get negative charge. We will study that in the next topics, that how a body gets charged. All right. What are the methods of transfer of charge from one body to another? But by rubbing a insulator, we get a charge at rest, as insulators charge cannot flow from one part to another. So where you put the charge on an insulator, it will stay there. All right. Another example is, you can try this at home. You can rub a plastic comb with dry hair. Take a plastic comb, the comb which you use in your home, rub it in your hairs, take it to the some pieces of paper, take a paper, make small pieces of it and rub the comb, and take nearby it. The comb will attract the pieces of paper due to charge on it. So by rubbing the plastic comb, where you rub that plastic comb, it will get charge there, and as the plastic is an insulator, the charge will stay where it is put on it, where it is created on it. All right. So this is also an insulator, and we have make the charge at rest on the plastic comb. You can try this experiment with a glass rod. You can rub the glass rod with your dry hair and try to put those paper pieces, and it will not work, as the glass rod, as the iron rod, when you rub the iron rod, it gets charged, but iron rod is a conductor, so the charge will start moving. It will go to your hand and from your body to earth, and the charge will not stay there where it is created, so it cannot put the pieces up. All right. It can only be done with an insulator. You have also seen many other cases of rubbing. Whenever in the winters you have wearing a jersey, due to whole day movements, the jersey is rubbing with your body and it gets charged. Whenever light is off and you are removing your jersey, you will see, you removing your sweater, you will see some sparking there. That is also a static charge. All right. So by rubbing you will get the charge, and also on if you get that charge on an insulator, it will stay where it is created. All right. Next method is, if you going to use insulator there, so you have to use an isolated conductor, not conductor, you have used isolated conductor there to make the charges at rest. All right. What is isolated means? Isolated stands for separated. Okay. All right. Not connected to anywhere, it is just separated from everything. All right. So I am going to take an metal sphere. This is an metal sphere, and this is put on an insulating stand. This is an insulating stand. What does insulating stand means? Insulating stand does not allow the flow of charges from it, as it is made of an insulator. So if I am going to give some charge to it, for example plus 5 coulomb, then that charge, as it is a metal, that is a conducting material, that can flow. Charge can flow on a conducting material. So charge will start flowing on the outer surface of this metal sphere, but this cannot go to ground, as this is an insulator. Charge will spread on that metal sphere, and finally it will spread uniformly, and after that it will stop. It will take a very less time, about of nanoseconds. Whenever you give the charge will spread on the outer surface of the metal. All right. So if I am going to another example. If this is not an insulating material, so the conductor is not isolated, the charge will go to the ground and charge will finish. All right. So you have to use the insulating stand, you have to use the isolated conductor, so as the charge does not go to the ground. So whenever you give the charge to an isolated conductor, the charge will spread uniformly over the surface of that conductor, and it will eventually come at rest. So in this whole unit, you need to charge is at rest. What you will do for the charge is at rest? Either you will give the charge to an insulator, or you will give the charge to an isolated conductor. You are not going to study any other cases in this whole unit wherever you will give the charge to an solid sphere, to an conducting sphere, to an hollow cylinder, to an solid cylinder, to an hollow ring, to a disc. Wherever you are going to give the charge, all the conductors are isolated, so as the charge remains at rest, and we will be able to study the effects of it. So this is how we are going to make the charges at rest. You will never study any conducting path between two conductors in this unit, as we have to make the charges at rest. Charge will not move in this unit. All right. So this was about the charges. What we have studied today. What is an electric charge? Electric charge is the property of any material due to which it can experience, or it can it can apply electric force to any another matter. All right. There are two types of charges, positive and negative. How come a body gets charged? It gets charged due to transfer of electrons. Please remember, it is electrons which get transferred from one body to another. Protons never gets transferred. As we know that the mass of electron is 9.11 into 10 to the power minus 31 kg, and mass of proton is 1.67 into 10 to the power minus 27 kg. And if you will take ratio of these, this will come about 1836. So proton mass is approximately 1836 times that of mass of electron. So proton is very massive particle than the electron. So protons actually does not move. It is electrons which get moved. So the transfer of electron is the reason of the body being charged. Why the transfer of electron? Because everybody wants to gain stability, and in order to gain stability, some of the bodies try to gain electrons, or some of the bodies try to lose their electrons in order to attain stability, and for that they want to complete their octet. All right. There are two types of charges. Like charges repel each other, unlike charges attract each other. All right. Then we have discussed that how we are going to make the charges at rest in this unit. I have told you that we are going to that by using insulators, or we are going to use isolated conductors, not conductors only, we are going to use isolated conductors. In the next lecture, I am going to discuss about the property of charges and how can we transfer electron from one body to another. And after completing the charge portion, we will proceed for the Coulomb's law. Thank you.